Hey everyone, welcome back to the channel. It's your Chiku here, and today we are going to dive deep, pun intended, into a super important chapter, water and solution. I mean, think about it. We use it every single day. But what's the actual science behind it? What makes water so special? Let's find out.
So yeah, that's the big question for today, right? What is it about this one simple molecule, H2O, that makes it the foundation for pretty much all life on our planet? By the end of this explainer, I promise you, you're going to see water in a completely new way.
So here's our game plan. First, we'll uncover water's secret superpowers. Then we'll see why it's called the ultimate mixer. After that, some tips and tricks on how to dissolve things faster. Then we follow its journey, all the way from the river to our taps. And finally, we'll tie it all together and see why this all matters in our world. You ready? Let's go.
All right, part one, water's secret superpowers. You know, before we can understand all the complex stuff, we have to get the basics down. These are the fundamental properties that make water, well, water.
Okay, first things first, let's get these very important numbers out of the way. These ones always pop up in exams, so pay attention. For pure water, the boiling point is 100 degrees Celsius, and its freezing point is 0 degrees Celsius. Simple, I know, but so crucial to remember.
Have you ever wondered how water can travel from a plant's roots all the way up to the leaves, fighting gravity? It's like magic, right? Well, the secret is two forces. First, you've got cohesive force. Just imagine water molecules holding hands with each other. Then there's adhesive force, which is the water molecules holding hands with other things, like the inside of that plant stem. Put those two together, and you get this amazing thing called capillary action that just pulls the water straight up. And you know that cohesive force we just talked about, the holding hands thing? Well, at the surface of the water, it's extra strong. This creates a kind of invisible skin that we call surface tension, and it's exactly why you see some small insects, like water striders, literally skating right across a pond without sinking. How cool is that? Okay, so everyone knows the formula for water is H2O. But how do we actually prove that? Well, scientists use a really cool process called electrolysis. You can think of it like this. An electric current acts like a tiny pair of scissors that snips the water molecule apart, separating the hydrogen and the oxygen so we can see what it's really made of. And this is where the proof comes in. When scientists do this experiment, they collect two different gases. And here's the kicker. They always collect twice as much hydrogen gas as oxygen gas. That perfect 2-to-1 ratio is the final, undeniable proof that the formula for water has to be H2O. Definitely remember this ratio for your exams, okay? Let's move on to section 2. So we've seen water's superpowers when it's by itself, but one of its biggest talents is being the ultimate mixer, or what scientists call the universal solvent. But what's actually going on when we mix things into it? Let's break down the different kinds of mixtures. Okay, time for some quick-fire vocabulary. Super simple. Let's say you're making a sweet drink. The sugar you put in, that's the solute. The water that does the dissolving, that's the solvent. And the nice, clear, sweet drink you get at the end, that is the solution. Got it? Solute plus solvent equals solution. Easy peasy. But you know what? Not all mixtures look the same. You need to know these three types. A solution, like vinegar, is totally clear. A colloid, like milk, is a bit cloudy, but the particles don't sink. And then you have a suspension, like if you mix chalk powder and water. It's very cloudy, and if you leave it alone, the particles will settle at the bottom. This table right here, this is a classic exam question, so make sure you understand the differences, okay?
All right, section 3. Let's get a little more practical. We know water can dissolve things and evaporate, right? But how can we control the speed of these things? Let's look at the factors that affect how fast things dissolve and turn into gas.
Just think about drying your laundry. Your clothes will dry much faster on a hot, windy day, right? That's because a higher temperature and more air movement, wind, speed up evaporation. And if you spread your clothes out wide, you're increasing the surface area, which also helps them dry faster. And, of course, they dry quicker when the air is dry, not all humid and sticky. See? It's all science. So what about dissolving sugar in your tea turmeric? Well, the same ideas apply. It dissolves faster in hot tea, not iced tea. That's temperature. It dissolves faster when you stir it like crazy. That's the rate of stirring. And it'll dissolve faster if you use fine sugar instead of a big sugar cube. That's the size of the solute. So if you want to dissolve something quick, heat it up, stir it up, and break it up. So we've covered water's properties. Now let's talk about something we all take for granted: clean drinking water. Have you ever really thought about the amazing journey that water takes to get from a river to your kitchen tap? I mean, really think about it. How do we turn that muddy river water, full of leaves, dirt, and who knows what else, into the crystal clear water that's perfectly safe for us to drink? Well, it's not magic. It's a huge multi-step industrial process. And here is that journey, step by step. Guys, you'll want to remember this exact order for your exam. First up, initial filtration gets rid of the big stuff, like twigs and leaves. Then, oxidation gets rid of any bad smells. Next is coagulation, where they add chemicals to make tiny dirt particles clump together. Those heavy clumps then sink to the bottom during sedimentation. Then, sand filtration catches any little bits left over. And for the grand finale, chlorination and fluorination, where chlorine kills the germs and fluoride is added to help protect our teeth. What a process.
But what if you need to clean water yourself, like when you're out camping? Well, here are 3 simpler methods. Boiling is great for killing germs, but it won't remove any dirt. A simple filter can remove the dirt, but it won't kill the germs. Distillation, on the other hand, is the ultimate purifier. It removes everything and gives you pure H2O. But it does take a lot more time and energy.
Okay, for our final section, let's zoom out. Let's connect all these sciencey ideas back to the real world and really understand why water is just, well, everything. So why does all this matter? Well, remember that capillary action we talked about? That is literally how plants drink. That whole thing about evaporation, that's how your body cools itself down with sweat when you're playing sports. And water's amazing ability to be a great solvent, that's used to make everything from your favorite soft drink to the detergent that cleans your school uniform. It's everywhere. And look, let's bring it right back to you. If there is one number I want you to take away from this whole explainer for your own health, it's this one. To keep all your amazing body systems running smoothly, you need at least 2 liters. That's about 8 glasses of water every single day. That's not just some random advice, that's science. You know, the great artist and inventor Leonardo da Vinci said it perfectly hundreds of years ago. Water truly is the driving force, the engine that powers our entire planet. From the smallest little cell to the giant oceans, it's the one thing that connects absolutely everything. And that brings us to my final thought for you today. We've seen just how special and complex water is, and how much work it takes to get clean water to us. So I'm going to leave you with this question to think about. What is one new thing you can start doing, starting today, to help conserve this incredibly precious resource? Think about it. All right, that's all for our revision today, class. Study smart, stay hydrated, and I'll see you in the next video.